Okay guys, so for 7.1b we're going back to domains, but this time we're working with just rational expressions. Now as a note, really quickly, what do we know when we have a fraction and I'm looking for the domain? How are we restricted? The denominator can't be 0, so let's put a note just up at the top. Okay, denominator cannot equal 0. And we're going to be using that for all of these problems. Okay, and it's just 5 examples. Okay, so example 1. We have f of x equals x minus 3 over x minus 2. So if I cannot have 0 in the denominator, we're only concerned about what will make that denominator 0. So we're only going to work with x minus 2. So we set up that denominator, x minus 2 equals 0. We're looking for what x is going to make that 0. And then how do we solve? We add 2 to both sides, and we get x equals positive 2. So how do we write the domain for this? We say the domain is all real numbers. X cannot equal 2. So what this is telling us is we can plug in anything except x can't equal 2. Anything except positive 2 will work. And that's our answer. Example 2. X plus 2 over x squared plus 4. What is the domain of that? Okay, so we set the denominator, because the denominator is the only thing we're really concerned about. We set that equal to 0, so we get x squared plus 4 equals 0. Okay, and then how do I solve for this? We subtract 4 from both sides first. This is not a difference of 2 squares because there's a plus in there. So we get x squared equals negative 4. Now what? We take the square root of both sides. So we are looking for x equals square root of negative 4. Is that possible? If we're not working with imaginary numbers, it is not possible. So what is the domain here? The domain is all real numbers. We can plug in anything. Taking the square root of a negative is not allowed when we're only working with real numbers. So since this has no solution, we can plug in anything we want. Okay? So let's just write a note down there. Since this is not possible, which means that up there, okay, since it's not possible, the domain will never be 0. Okay? So we can plug in anything we want. Okay? Example 3. F of x equals 3x over x cubed minus 25x. So example 3. F of x equals 3x over x to the third minus 25x. Okay, same thing here. We are only concerned about the denominator, so I'm going to set that denominator equal to 0. So we have x to the third minus 25x equals 0. Okay, and we want to factor this thing. So how can I factor this guy? There's a GCF of x, so we're going to factor out the x. And that leaves me with x squared minus 25 equals 0. Now that is a difference of two squares. So this is x times x plus 5, x minus 5 equals 0. Now I have three things here, so how am I going to solve? Good. Set each one equal to 0. So we set x equal to 0. We set x plus 5 equal to 0. And we set x minus 5 equal to 0. So we have three things we're worrying about here. Okay, x equals 0. Can I go any further than that? Nope. So we know that that's an answer. What about this one? We subtract 5 from both sides, and we get x equals negative 5. And what about this one? We add 5, and we get x equals positive 5. So what is my domain? My domain is all real numbers, except x cannot equal 0, negative 5, or positive 5. How can we write that? Plus or minus 5. So when we're dealing with rational expressions and their domains, the domain is always going to be all real numbers except whatever we'll set it equal to 0. Because we can plug in anything else we want except for these three numbers. Okay, does that make sense? Okay. Okay. When is this statement true? 5x plus 5 over x plus 1 equals 5. When is that true? Okay. So before we get too stressed out about this, let's look at the function right here. Do you guys see anything that we can do with this guy before we start working? We can take out GCF from the numerator. What is it?
5.
It's 5. So let's pull out the 5. And that's going to leave me with x plus 1 all over x plus 1 equals 5. Okay, now what? Now those guys cancel. And what would I be left with? 5 equals 5. Is that true? Yes. So this is a true statement for everything except one number. We still have to look at where the denominator would equal 0. So if I set x plus 1 equal to 0, I subtract 1 from both sides, and I get x equals negative 1. Okay. So what's my domain here? When is this true? It is always true. Except when x equals negative 1. Okay? So the reason we wanted to factor and cancel out first is to check that we would still end up with 5 equals 5. If we ended up with something that did not come out to be a true statement, so for example 3 equals 5, it would never be true. Okay? So we wanted to end up with 5 equals 5 first to check that it was a true statement. Okay, then we still have to check the domain. Where would that denominator equal 0? So this will always be true except for the one point where x equals negative 1. Okay. Last one, example 5. Same thing, when is this statement true? But our function is 3x minus 6 over 3 equals x minus 2. Okay, so what do you guys think we have to do here? There's a GCF of 3 out there, so we're going to take out the 3, and that leaves us with x minus 2 over 3 equals x minus 2. Okay, now what? Now those guys cancel. So I'm left with x minus 2 equals x minus 2. Is that a true statement? Yes, it is. Okay, so this is true. It will work for any number. Are we restricted in the denominator here? No, because we have just a 3. There's no way that could ever equal 0. So what's my solution here? It is true for all values. True for all values of x. Okay, make sure that in your notes you word it this way because these are multiple choice type questions and they are worded exactly the way that we have it all written down. Okay, so just so that we're prepared for the type of wording we're going to see. And that's it for domain.